my name is Yujian. I'm a developer advocate at Zilliz. So I take my coffee, 2 shots of espresso over ice with sparkling water and a pump of caramel, and then some milk to mix.
Welcome back to the MLOps Community Podcast. I am your host, Dimitri Os, and today we're talking with Yujian. What a conversation. We went real deep when it comes to RAGs. I know it's everyone's favorite topic, or at least it was in 2023. Let's see how 2024 shapes out. Maybe you are bored of them or tired of them by now, but I promise you, we got into some caveats when it comes to RAGs. There's 1,000,001 courses or pieces of content that have come out around RAGs. And so how can we differentiate ourselves? Well, we talked about some optimization methods that you might want to consider when you are using RAGs. We went from what the hell is a RAG to how do I optimize it and what do I need to be thinking about at the deepest level? How am I building my app so that I can take full advantage of the pros and cons of each design pattern and these dense vectors and sparse vectors and all that fun stuff that all vector database people like talking about, I guess. So if you are doing anything with RAGs, I would love to hear from you. To be honest, I would love to hear what you're working on. And if you decided against RAGs, I would also love to hear from you, because the beauty of this is that RAGs, as we talked about with Yujian, they're not for everything. Although you may go on Twitter and hear that you can just throw some AI at it and have it be a RAG or use a RAG with it. You don't need to. And the last part, I think Yujian has some cool insight around multimodal RAGs and what we can do when that starts taking off and when support happens for that more. So if you are on the market for anything vector database, check out Zilliz Cloud and check out Zilliz Pipelines, their new feature that they just have for early access for the community and listeners of this podcast. You can find it by clicking in the show notes. And huge thanks to Zilliz for sponsoring this episode. Of course, if you liked it, share it with just one friend. That's all I ask. All right, I'll see you in the conversation. Dude, well, I'm stoked to have you on here. I want to do like a huge deep dive into RAGs and basically where we're at right now. It's 2024. RAGs have become the hero of the LLM space. I think it's more or less the QA bots are like the hello worlds that you create with LLMs. And I know you've been spending a lot of time working on RAGs and their implementations and all that fun stuff. So we should probably start with, we had you on last time, and we'll link to the last podcast that you came on in case anyone wants to basically hear. I'm not going to say it's part 1 because we're going in a totally different direction. It's not like you need to listen to that one first before you get to this one. But we did have a pretty insightful conversation around vector databases and the idea of how much AI has been accessible by the masses now because of things like vector databases and LLMs. And so, whereas before it took quite a lot of effort and a lot of engineering time to get some kind of ML model into production, and that was really the thesis for the MLOps community from like 2020 till 2022. Now it feels like we're in a place where we can get something, at least something quick and dirty, up and running real quick and validate assumptions, validate different ideas that we might have. So before we go any further, the vector database /LLM /embedding design pattern is probably the one that everyone thinks about when it comes to RAGs. Am I correct? And correct me if I've gotten anything mistaken there.
Yeah, that sounds about right for most of like what people like ask about when it comes to like the RAG stack is like what are embeddings? How do we get embeddings into vector databases? Like, are embedding models and LLMs the same thing? And they are not the same thing. And this is like something that quite often gets asked. And people once they look at these different applications, like using, like if you're going to use LangChain, if you're going to use Llama Index, and you're going to do RAG, you're going to have an embeddings model and you're going to have a LLM, and people will ask do they have to be the same? And the answer is no, they don't have to be the same. It's like, oh, well, how do I pick one? And then, it gets a lot more complicated than just like the very basic, like use the default, here's OpenAI, boom.
Mm-hmm. Yeah, and embedding models, it's probably worth just a quick summary too for the two people that are listening that have been under a rock and do not know how embeddings work and vector stores work with embeddings and what you need to do there.
Yes. Okay. So yeah, I probably should have more clarified what these pieces of the puzzle were. So embeddings models are the models that you use to turn your data that you're going to be working with. This is your proprietary internal data or whatever, and you turn that into vector embeddings so that you can work with it, basically, because embeddings are numerical representations of this input data that is like a text or image or something. It's like a machine learned using a machine learning model representation of this kind of data. And embeddings, embedding models are trained. Well, now we've moved far along enough into the RAG staff that people who are working on the more like cutting edge stuff, I think this probably came to light a few months ago. Like the whole, you need to be training your embeddings model on specific types of data that you want to work with. Like you can start off by going to Hugging Face and getting like a very basic embeddings model. Yeah. And it will work decently fine. But when it comes to like enterprise production and when it comes to working with very specific data, you're going to need to make sure that you're training your embeddings model on the right data. And then what these embeddings models do, or what we do with the embeddings models, what you need to do with the embeddings models in order to get the embeddings from them, is you actually, after you train the model, you need to ensure that you're only taking the output from like the second to last layer. So traditional natural image processing models will, or even image models, they'll do some sort of, like image models will do some sort of segmentation. Natural image processing models might do some sort of classification, some sort of prediction, something like that. But with the vector embeddings, that's not what we're looking for, actually. We just want to know what the semantics the model has pulled out of the input is. And so that's why instead of taking the output of the model, what we actually do is we take the output from the second to last layer. And then just to touch on the LLMs and the vector database, in case there are other people who have not heard about these yet. LLMs are the large language models, right? GPT, everybody kind of has heard of that one. There are many others, right? Like Mixtral came out. I think Perplexity is coming out with another one.
No way.
I don't know. There's like a huge number of LLMs now. Falcon, Llama, basically everything you can think of is an LLM. I also I have like a personal gripe on this, is at this point, I don't even know what makes something a large language model anymore. How large does it have to be, 7,
Totally.
13, 20, a trillion parameters? I'm talking about billions with these first few numbers. And then I heard someone saying oh, actually I think anything under 7 billion is a small language model. And I was like, I don't know, it seems pretty big to me.
Yeah,
just
a 5
literally
or a 3. Yeah.
Right. Yeah. Literally last year we're large language model with 5 billion parameters. And now it's kind of if you don't have more than 10 billion parameters, is it really a large language model? I don't know. And then
I'm guessing you don't get the stamp of approval of being large. You're not large enough. And it is funny because a lot of people are coming through and saying, this year it's all about the small language models. And so now it's who's deeming what is large and what is small? Have we come to a consensus on that yet? I don't think so. So
I don't think so either. And these people are we're going to be talking about small language models, and they're going to be talking about 3 billion parameter models. I don't know, man. And then the last part is the vector database piece, which is where you store your vector embeddings once you get your vector embeddings. And you basically use this as a semantic store as a way to store the meaning behind the image and the text and the audios and the videos that you have, and a way to work with that semantic meaning in a mathematical manner.
Yes. And now land the plane. What does it look like when you're actually building the application? The end user will, whatever, type into their Q&A bot.
What does the end user actually have to do?
Well, I think I'm more just thinking the end user will type into the QA bot, right? Like, I'm looking for more examples of this, or whenever it says that, and or tell me about if I'm reading a book or I have a bunch of PDF documents, tell me about this paragraph more, or where it talks about this more, right? Then behind the scenes, what happens?
So there's okay, so actually the way that a user is expected to interact with the app also plays into like the way that you should think about designing your app. But we'll touch more on that in a bit. So what actually happens behind the scene is, so there's a few ways that you can structure your architecture, and it depends on how you would like to build it. But what I would suggest, this is my suggested architecture, is what happens behind the scenes is the query comes in, it goes to the LLM for the LLM to determine what the actual question is. So perhaps you have like, you want to give it some context. You want to say like, pretend that I'm I don't know, like an astrophysicist, and I'm reading this book about the cosmos, and I want to know about black holes or whatever. So then, it gives it some context. It pulls out like what it actually is. And so when you say that, the LLM has to know that, okay, well, actually what I want to go look for in the database, let's say you have a database of books, is I want to go look for, and I want to filter on the book Cosmos, and I want to look for black holes. And so what it will do is then it will say, okay, it'll form a way to query the vector database. And so vector database queries are typically formed in like a call, right? Like either some sort of like API call, some sort of HTTP, gRPC, some sort of call like that. So it's passing data along. It makes some sort of call to the vector database, and it says, okay, let's filter on this book and Cosmos. We're only going to look for text about black holes. Okay, so then maybe you get 10 responses back, right? So you get 10 responses back, and then you send those responses back to the LLM. And you give remember the first query, it's like, okay, we want to know about black holes from this book. And then it says, okay, here's my response. Here's what it is in the vector database. Here's the book name. Here's the section name, the chapter name, the author name, and like all this information. And then what it'll do is it'll take that information, it'll crunch it down and say, okay, here you go. Black holes are, supermassive clusters of gravity or something. I'm not really sure what they are, but then it'll return the answer to you basically. So what goes on in the background is basically the LLM first takes your input and then interprets it, turns that into a query, queries the vector database, takes that context, and then turns that context into something that's human readable and gives you back something that makes sense.
I was really hoping you were going to give me some crazy definition of a black hole right there. I like there was a miss, but we can hopefully edit it back in post-production.
I don't have any crazy things about black holes. Let me think if there's anything I know a lot about that would be like fun to know about.
The fun fact. I do appreciate, this is just like a little bit of a side note and a tangent, since we are going on a little tangent here. I ask speakers of the podcast to fill out a speaker form when they come on to this podcast. You filled that out, and one of the questions on there is a fun fact about you. Do you remember what you put for your fun fact? You said, I can build a fire. Is it like Boy Scouts fire where you're just kind of in the woods and you have flint and that stuff, or is it with a whole bottle of kerosene?
Yes. So I don't know why, but that was like one of the first things that came to mind for that question. And I am really proud of being able to build a fire because of like one specific instance, which was like, I was down in Coronado Beach with some friends, and we brought like Korean barbecue, and we brought like something to cook it on, and we brought like a bunch of things, but and we had like firewood and all this stuff. And then we were having a lot of trouble like starting the actual fire, right? like you got to imagine like you have like, you know, three kids who spend most of their time in front of computers, like, you know, think like, you know, very like nerdy, like, I mean, I come from a software background, right? So you've got these three kids who spend basically like 20 hours a day in front of a computer, and they're just sitting at a beach trying to figure out how to like start this fire. And so we actually get the fire started. So first we figure out like, okay, we're just going to go around and find like dry leaves and like stuff like that. And it finally works. Oh my God, we poured so much kerosene on it and we couldn't get it started. But what finally worked was like, we got like a bunch of like dry leaves, and then we got the kerosene on the big logs, and it finally caught on fire. And then it wasn't like the right type of fire, because like we were trying to like barbecue something, and like it was like a TP stick fire. And so we had to like rearrange it and all this kind of like random shit. So it was a very fun time. It was probably like my first time ever actually building a fire, and that was like just like one random thing that like came to mind when I was filling out the form. So I was like, okay, here we go.
So the mental picture that I have in my head of the three of you trying to build this fire, and you're used to writing unit tests and all that fun stuff, and there's no unit tests for these fires. It's like,
there's no unit tests.
Do we need more kindling? Do we need more gasoline? Let's just go get gasoline and dump it on this and see if that'll work. So this, as you were telling this story, basically, I was thinking about the parallels in what I just did to get more context out of you on this fire.
Mm-hmm.
It was like I was a rag right there. Yeah, I was I was a human rag, because you said I can build fire, but then I said, give me more context. I need more context. And I went to the vector database, which is you, and I got more context. And now I can plug it into the LLM, and I can say, all right, here's all the context you need about Yujian's fire capabilities. So
exactly.
We went on a huge tangent there, man. I want to get back on track. And for those that are listening, I promise we're going to get deep into the rags and rag stack. I like that word that you used. It's good. One huge question that is on my mind when it comes to rags, I'm sure you've heard a lot of people talk about this, is do rags eliminate the ability for LLMs to hallucinate because you give it that context?
No, it doesn't. So this is something that we talk about a lot in like many of our earlier presentations, and I think a lot of people talk about this when it comes to RAG stuff, is like, you know, RAGs can hallucinate. How do you get rid of that? Well, you should use like some sort of context to inject your data. And injecting your data it reduces like a certain like type of hallucination. Like, you know, it's not going to just like make things up about your data anymore. But that doesn't mean that it's not possible for the RAG to like still like put out the wrong answer. Because in the end, like, the way the LLMs work is still using statistics, and it's still just like, here's the context, I'm going to predict based off the context. But if the training data was weird and the context contradicts the training data, you might get some weird results. And so an important thing to do to kind of like deal with that is basically to have your observability tools and have like, you know, your evaluation tools afterwards. And I think that's part of like the whole reason that there's so many tools that have recently kind of like moved from what was originally like MLOps into now what they're calling LLMOps.
Yeah, and do you feel like that is a critical part of the RAG stack?
Oh, for sure. Like, if you're going to be doing this in production, like, you don't want, like, you got to know like that your answers are like decently like right, like not like even humans, like, you know, no human is right 100% of the time. But you know, like, you got to make sure that your rags are at least matching up to what people are capable of. And so like examples of like, you know, some of the things that people talk about in this space, like, make sure that the context that you get is relevant, right? Just because something is semantically similar doesn't mean that it may necessarily be semantically relevant. And make sure that, you know, you cite your sources, right? So this is something that I was building earlier last year using Llama Index, was like, how do you build a RAG app with citations? And how do you ensure that, like, you know, the actual answer given doesn't deviate too far from the the data that's pulled back from the vector database.
And how did you do that?
Building citations is actually very, very easy. What it kind of requires you to do is to realize that you're going to build an application that's going to need citations. And so you have to store the text that you're going to use along with your embeddings. So you're going to store more data, but you're going to, in return, you're going to get that groundedness and that context and that relevance and that ground truth data back. And then actually, so this was something that wasn't originally available on Llama Index that I actually ended up writing a PR to make this available.
Nice. Yeah, it's almost that trade-off of, hey, we're going to store more data, but we're going to have more trust. So
yeah,
it's worth it 100% of the time.
Yeah.
And you said something else that's interesting in there that I wanted to just dig into for a second. The context and relevance, like what's the difference between those two there?
Right. I think it probably makes more sense to differentiate between like relevance and similarity. I guess these are both like attributes of context. I would say, but context is like the additional data or the data that the original form of a data or like the data that I don't know, like the surrounding data for something. So for example, like an apple a day keeps the doctor away. Like you need the context that the apple you're talking about is a fruit and not like the Mac, right? The laptop. So context is kind of like that. And then similarity and relevance is like, let's say I want to find something for an apple a day keeps the doctor away. And maybe a similar sentence to that might be like a banana a day keeps the chiropractor away. But is that...
You just made that shit up, didn't you?
Yeah, I just made that shit up. But is a banana a day keeps the chiropractor away relevant to my question about, what keeps the doctor away? And not really. So that's kind of like the difference there is like, like what would be relevant might be like, an apple a day keeps the doctor away because it makes you eat fiber. I don't know, something like that.
Yeah. Fiber, it's a big one these days. Get that gut health right. And you won't have to see the doctors. Yeah.
Yeah, I just heard a podcast about it, so that's why I was thinking about it.
Was it the Peter Attia one?
No, it was like one of the ones with Andrew Huberman.
No way. All right, I got to go watch that now. That's on my list. I just watched the Peter Attia one, so... Okay, so now I want to just make sure that I'm getting this right. Just a little pause, because the RAG stack, we introduced something new into it that we didn't have in the beginning when you said, oh, these are the things that you need for the RAG stack, which is the embedding model, the LLM, and the vector database. But then we just said, oh yeah, and by the way, you might want to have some kind of an evaluation / guardrails tool on there. And funny enough, I'm sure you've been seeing some of this stuff pop up on social media where I think it's Chevrolet. If you go to the Chevrolet website, they use an LLM for their customer service bot, and it's just straight plugged into GPT-4. And so I've seen people talking about how like, why pay for OpenAI when you can just get it through Chevrolet's website? Or I've also seen people asking like, are Teslas better than Chevys? And it will come back like, Teslas are known to be better than Chevys, yes. On the Chevrolet website, it's just like the amount of brand damage that you're doing right now is incredible. So it's worth its weight in gold to get some kind of tool that will make sure your RAG is not spewing out things it should not be spewing out.
Yes. It is definitely worth looking at doing something like that, and you definitely need something like that when you're going to be putting this into production. I guess since we're on the topic of tools that you can add to your RAG stack, other things to think about could be like data pipelines. Like, for example, how do you pipe new data into your vector database? And this is actually something that we have been building at Zilliz. So Zilliz recently released our own like pipelines thing, and so one of the things that people always ask me, like I'm pretty sure I think I did like 14 talks last year, and I got this question at least like 12 or 13 of them, which was like, how do I get my data into a vector database? And it's like, oh, well, you need to use the embeddings model, but like, you can make it easier by building a pipeline around it or something like that, right? So for what we have for Zilliz right now, we have an open source model as our embeddings model on pipeline. But like that's kind of just a one way to get into it, right? We want to offer people a way to get into it and to think about using pipelines, because when you're in production, you probably don't want to. I mean, you could, I guess. People actually do this in production. You could just every day or so execute a script, runs for 10 minutes, put your data into your vector database.
Hey everyone, my name's Aparna, founder of Arise, and the best way to stay up to date with MLOps is by subscribing to this podcast.
But if you want like a more automated version of that, like if it starts taking you too long to go and do the script, then get a pipeline, right? And Zilliz pipelines aren't the only pipelines that are available, but this is like one way that you can use a pipeline to pipe your data from some sort of data source into your database in a more, let's say, streamlined, automatic, easy, whatever kind of manner.
Yeah. So then basically, if I understand this correctly, it's like, as we build out this RAG stack in my head, we've got the LLM, we've got the vector database, we've got the embedding model. We need a way to connect that and connect all of these, along with, on the output, we need a way to make sure that there are guardrails and that we validate the output before the end user sees it. Is there anything else I'm missing there? I feel like probably potentially some kind of prompt tooling.
LangChain, Llama Index, these are orchestration frameworks. I guess prompt tooling, prompt engineering kind of frameworks also kind of like if the shoe fits, I guess. So that would probably be like one more thing in there. I have seen that a lot of people like to also do their own prompt engineering. And I think that is actually something that, I would really like to see, this is a feature request for the LangChain Llama people if they're listening. I'd really like to see a way to mess with the prompts inside of the apps, which is I guess it's kind of weird because it kind of defeats the purpose of the apps themselves. Like, the frameworks themselves are supposed to be there to give you this way to interact with the LLMs. I'm not sure, but that's something that I think is like, if you're working in production, like you're probably going to want to tweak your own prompts.
Yeah. Yeah. You want easy access to that. You don't have to dig around. That's for sure.
Yeah.
So the other piece that I am fascinated by is, I think some people have come and asked about, why would you need to use RAG for some use cases? Is it not good enough just to use like search?
Like keyword search?
Or similarity search for that matter. Like, do you need the whole throwing it into an LLM and getting a bunch of output? Or can you just do search and have it give you back something? Like, is LLM over-engineering it just because of the hype?
Yeah. So for this, I would like invite you and other people to kind of consider like a thought experiment, which is, let's say I have semantic search and I ask the question, what ingredients are in an apple pie? When I do a similarity search for that, I'm not going to find like an answer that says you need 3 apples, a pound of butter, a pound of flour, whatever. What I'm going to find is things like, what are the ingredients for a blueberry pie? What are the ingredients for a pecan pie? And that's what I'm going to get back. And so if you think about it in that manner, you'll quickly recognize that you need something that's going to take your natural language query, your question, and turn it into, how do I find the things that's going to be similar to the answers to this question?
Yes, I see. That makes 100% sense. Yeah. And it's like, we want the answer. We don't want the similarity of this question.
Correct.
I should have known that. I can't believe I didn't know that. And I'm asking you that. Now that I think about it, I kind of feel like an idiot.
It's okay. This is a very common question that I also get.
Good. So one other piece that I'm wondering is like, what kind of RAG optimization do you do, and should we be thinking about? Like, let's say we've got the RAG up and running, but now we want to make it better. What are some ways that you can turn some knobs and levers you can pull?
Yeah. So I think this is part of where some of the pre-processing stuff comes in. And this is also something that this comes before the embeddings model, which is thinking about how you want to chunk up your data. How do you want to split up your data? And earlier, when we were talking about like the end user and how the end user is going to use the RAG app, I referred to this, I alluded to this, like, oh, we'll cover this later.
Foreshadowing.
Yes, foreshadowing. When you think about the way the user is going to use an app, it also makes you think about the way you want to chunk up your data. So for example, if you want your user to use your app in a conversational manner, like it's going to be a chatbot, then you probably can chunk up your data into smaller sections. Like, it's like, oh, okay, like we probably need to find very specific, very like small kind of things. But if you perhaps want your user to use your application as something that helps them complete blogs or writing things, kind of like what Jasper does or Copy AI, then maybe what you want is you want to give it more data that is an example of bigger blocks of paragraphs. Or maybe also like, depending on not even getting to the part where we talk about what the user is going to do, but maybe let's think about what data you are working with to begin with and what does it look like. So if you have data in the format of a conversation of like a text back and forth, then you're going to want smaller chunkings, and you're probably going to want to chunk on specific characters. Maybe you have specific characters to separate new text blobs, and you're going to want to chunk on that. And then, if you have a big document, then you're going to want bigger chunks. If you have maybe a QA or a lecture where there's going to be like a short and then long answers, you're going to want a way to chunk on specific characters, and possibly also you're going to want to be able to save coupled texts. And then one other thing to think about with that is how much context overlap do you need between your data chunks, right? So maybe you have a document and these paragraphs are like 500 characters, but you need the sentence before and the last one of the last sentence of the paragraph before and the first sentence of the paragraph after. Then you're going to need some sort of chunk overlapping, right? So there's a bunch of like different things to think about when it comes to how am I going to set up my data to even embed. This is like prior to building your RAG app. Like you can build an example one, and then once you build an example one, you probably want to think like, okay, there's definitely ways I can make this better. How do I make this better? The first step you're going to want to look at is what does my data actually look like inside of the application? And then of course the eval stuff.
Yeah, that is really interesting when it comes to this idea of like start from the end and then go backwards and recognize how you can optimize that way. And I also look at like other ways that we are interacting with LLMs as far as like the point and click ways that we're doing it too, right? Like I think about Notion AI, and that's a great interface of it. We don't have to use it like a chatbot, but we can if we want to. So if you have all of those options open, how are you then thinking about optimizing in the background? You know what I mean? Like, do you do both and then just sacrifice on the storage like we talked about before, where yes, you are going to store more, but you're also going to have more trust? Or is it something like you're finding that happy medium?
Yeah. So there's actually, I have something to touch on that as well. So there's a couple ways that you can even think about storing. The way you store your chunks and embeddings can also affect the way that your application works. So a couple of techniques that I've talked about in some of my talks have been like, you can store larger chunks of data with smaller, with only maybe one of those sentences embedded, and you can use that as the embedding. You can store the entire chunk with it. Then you get more context every time you have, specific things that you're looking up. The other way is that you do the reverse. So you you embed an entire paragraph and maybe you only store a sentence. And that way you can get more specific responses to a more generalized query, perhaps. So there's a couple different ways to kind of address that as well, just like the way that you store your data. As for the trade-off there, I actually haven't seen this in production, so I'm not entirely sure exactly how the trade-offs work, but it sounds like kind of once again, one of the many trade-offs that we make here is like compute versus storage, or storage versus latency, or storage versus quality, or things like that. And this is just another one of those things that we'll have to optimize for when we build in production.
And along those lines, what are things that you feel like RAGs are not suited for? Because it feels like you've seen a lot of square pegs trying to be fit into round holes, right? Just because RAGs are RAGs and they're the hype these days.
Yeah. What are RAGs not suited for? I mean, really, you can use a RAG for anything you want. I don't know how well it'll work.
Just throw all your data in the vector database and use it for whatever you need. We got you covered.
Yeah, exactly. Throw all your data in the Milvis, use it for whatever you need. We got you covered. Someone asked me the other day, they were like, oh, I want to be able to map all my users, and I want to be able to track all my users, and I want to map them based on specific characteristics that I've predefined for them. And so I'm like, well, then you're not even looking at unstructured data. You're looking at structured data. Like, go use a SQL database and write an automation. Like, that's what you should do.
Yeah, don't complicate your life.
That's a great example of like when to not to use RAG. Okay, there you go. I don't get a lot of people asking me about. So like a lot of people just ask about RAG because it's like familiar, but it's also like different, right? People are like, oh, this is like, we've seen this before in like 2013 and like 2000 whatever, like the chatbots that pop up, and people are like, oh, it's a chatbot, and it has that familiarity to it. But then when it comes to actually using them and building them, and it's like, how do you make these better? Then it's kind of interesting. It's kind of different. People like that. So I would say anything that you can think of that, relates back to chatbots from 2013, then use RAG to replace that. Things like, actually, I have a great example of something that might not need an LLM for, like similarity search. So I recently talked to somebody who's building some sort of like fashion AI tool, and I build like a couple of these myself for fun. And one of the things...
Wait. You got to go a little deeper into that. Fashion AI, I didn't take you much as a fashionable guy there. No offense, but I feel like you wear a uniform of a t-shirt and jeans or sweatpants maybe every day, and you're often on your free time building fashion apps. What's going on there? I need more context. I need to do the LLM thing, the RAG thing again.
I'm not necessarily a fashionable person, but I just like, it's just like a fun thing to mess around with. Everybody wears clothes, and a lot of people wear clothes and they look kind of foolish. And
Myself
maybe
included.
Yes, me too. Like I get, I get it. So, but some people wear clothes and they look really nice. Like when I was at AWS, I saw this one lady very dressed up. She had like this nice peacoat. Like, I don't know a lot of the words for some of the other things that she was wearing, but I was like, wow, this person looks really put together. And you like look everyone else, and everyone else is wearing like a tech shirt. Like I'm wearing a tech shirt and like jeans, sweatpants, walking around, and like I'm like, oh, okay. I don't know. It was just like a thing that kind of like popped into my mind, like it'd be cool. It'd be fun. So I built one.
Okay. And now we have more context. Yeah. Give me what you were going to say. What was the takeaway? Sorry. I totally derailed that. I had to know what is the context there.
Yes. You don't need an LLM to convert your picture of a dress into the description that this is a picture of a dress if you have pictures of dresses in your vector database. So that's an example of something that's not a RAG app, doesn't use an LLM, still uses a vector database. Similarity search.
Okay, but you're not using Clip or anything like that to get the metadata around that?
You can, the person who built this fine-tuned her own like segmentation model.
Okay, nice.
I was like, wow, I personally wouldn't put that much effort into building a fashion app, but I'm glad that you did, because this is cool.
All right. So wait, what did your fashion app do?
I basically found like an open source like segformer, like segmentation transformer thing, and it just like segments out like it like clips like your shirt and your pants and whatever, and then it matches it to other pictures. I had a bunch of pictures of Taylor Swift, a bunch of pictures of like random celebrities, and just like put them up there and was like, match your outfit to Taylor Swift or match your outfit to some random celebrity, and just like
nice.
threw them in there and was like, all right, here you go. You know.
Oh, I'm gonna go see if I can match my outfit to Taylor Swift now. Give me the link for that. What is it? Is it live? All right, we're gonna put this in the show notes for anybody. Okay,
it's on GitHub. It's on GitHub.
We will
We'll
put
find
that.
it. Oh, here it is. Fashion VDB. It's actually kind of it's yeah. Here we go. I'm gonna drop it in here.
Yes, I love it. This is awesome.
It's not super simple to run. You have to run like the ingestion, and then there's like two things you have to run. I think like one is like ingest, and then the other is like, oh no, one is set up Gradio fashion, the other one's Gradio fashion, and then just you get a nice UI, drag and drop, see pictures of Taylor Swift compared to you.
Oh, I love it, dude. That's cool. That is really cool. And you didn't need any LLM to deal with that, and you don't need to do RAGs at all for that.
No LLM, not a RAG
You don't
app.
need to overcomplicate things. But it's not. Is it giving you a recommendation of like what you should wear if you want to look more like Taylor Swift?
It's just like it's just like your outfit looks kind of like this one.
Oh,
It's not that far along. It's not like
okay.
like here's what you should wear.
I see. All right, cool.
I don't really think that like I'm not really sure that like I would be qualified to be telling anybody like what they should be wearing, you know. You need someone with like some background on that, you know, like, oh, this person's a fashion designer. Oh, okay, that makes sense, right?
There you go. And so if you were to make this into a RAG app, I feel like you could do a few things where maybe you're recommending, it is that recommendation on how do you make this outfit look better or look more like Taylor Swift, and then you send it to the LLM and it will give some kind of a recommendation.
Yes. So first step, this could be easily a first step into launching a multimodal RAG app, right? Like you've got images and you want to do RAG. So now you've got text, you got images. This is perfect to get into multimodal. What you could do is you could have some sort of LLM or ClipVit or something like that and be like, describe the pictures to me. And now you can search the pictures. So instead of putting a picture of yourself and finding like one that's close to whatever, Taylor Swift, you can be like, oh, show me a picture of Taylor Swift performing at a concert in a green dress. And it'll look at the pictures and it'll pull like, oh, okay, here you go. Or you can give it a picture of you and be like, describe what I'm wearing in this picture. And then it'll describe what you're wearing. And then you can be like, find me a picture of Taylor Swift wearing something similar to bleh. And then it'll find, a picture of Taylor Swift wearing something similar to whatever it is that you're wearing.
And are there any considerations that we need to be thinking about when it comes to multimodal RAGs versus just the LLM RAGs?
Oh man, I think that we are just on the tip of the iceberg with multimodal RAGs. I think that 2024 right now we're talking about multimodal RAGs. There's not a lot of these that have really been built. I haven't seen any in production yet. I think this is the year that a lot of people are going to build them. We're going to see a lot of things that people are going to run into. I think one of the problems that we're going to run into with multimodal RAGs that I have no solution for, that I haven't heard any solutions for yet, is just the fact that there is a likelihood or a possibility or a probability, let's say there's a probability that your LLM is also going to hallucinate on what's in the image. And so now you have two steps of hallucination. So you have a hallucination of what may be returned and a hallucination of what may be in the image. And so I think this is going to be something that is going to be kind of the next, like as we use the LLM more and more in LLM applications, I think one of the main issues is going to be this issue of reducing compounded hallucinations.
Yeah, because if it hallucinates once, then it's going to create downstream effects and it's going to be much less reliable. Yeah, that makes a lot of sense. And then to debug that also is not as straightforward as where did it hallucinate? You have now 2 points of failure, not that single area where it can be hallucinated. All right. And any other ideas on apps that are of interest when it comes to using multimodal RAGs? Like what are some other use cases that you've seen or that you are thinking about?
I've heard requests for video search or catalog search for people. I think video search, if you're going to do true video search, that's going to be computationally expensive. That's going to be tough.
Why do you say that? Just because it's frame by frame?
Yeah. I mean, how many frames do you have? And then it's not just like the frames, right? Like when you have a video file, it's not just the images, you also have the audio, and they have to match up. And so you can't individually do image audio stuff on videos. You have to do it on video files, right? I mean, you can try to do it with image audio stuff separately, but you have to work it on the video files themselves. And they just take up more space. They're memory heavy. They have a lot of numbers, so they're naturally compute heavy. So I think that's going to be an interesting space. It's going to be kind of tough.
And just so we're clear on that one, I feel like the multimodal can be one. Imagine we are having a chatbot that can chat with a movie, and you have different parts of this multimodal, which is one, all the frames in the scene, and then you have another, which is all of the audio that comes out of that, and then you have another, which is like the script that I imagine you could try and get, right? So there's all those different pieces that come along with it.
Yes. There's the frames, the audio, the script. You can turn the audio into images using MFCC. You can... One thing that I really would like to see, and I think this is going to be quite tough for people to build, is like video to video search. Like, I want to know, like, hey, like I see this. All right, this is gonna sound really nerdy. Okay, so I'm watching this like Naruto like music video, right? I want to see where these clips are coming from. What episode is this from? What did I miss? Because a lot of times I'm like, I haven't watched all of the series. But like sometimes, like, you know, I'll be like, oh yes, this is cool. Like we'll watch one of these, and then I'll be like, oh, where's that from? You know?
Nice. Yeah. So it's almost like what we were talking about before, where you have citation. You have citation in the videos.
I want to see citations for videos.
Yeah. There you go, dude.
I think
awesome.
We're a little bit away from that, but it would be cool. Yeah.
But I mean, a little bit away, as in this year or this decade.
Oh, I think I would be surprised if this wasn't solved in this decade. I would not be surprised if it wasn't solved this year.
Okay, cool.
Or solved, mostly solved, let's say.
Yeah.
Usably solved. Solved.
Yeah, that first iteration. Dude, well, this has been fascinating. For everybody out there who wants to play around with the pipelines that you were talking about, we can just go to zilliz.com/pipelines or Google Zilliz pipelines.
Sign up for, you can just cloud.zilliz.com, sign up for a free account. If you spin up one of the serverless options, the serverless option is the free option. You get immediate access to pipelines, and it's in the UI. You can click around and build your own.
Excellent. And if you do that, make sure they send out, I think you mentioned you send out a feedback form to anyone that does that. And so in that feedback form, let them know that you listened to this crazy chat that Yujian and I just had, and let them know that we sent you over that way. It would be great to hear that. Man, I am still impressed that you can build fire, and I appreciate you coming on here and talking with me. This was brilliant.
Hey, Laszlo here. If you're serious about MLOps, you hit subscribe right now.